Okay, this is where we had left off with last time in discussing our series on chemical reactions. And up to this point, we've been working on choosing coefficients to balance out some of these chemical reactions. And as you can see, one of the aspects we talked about yesterday is sometimes it just involves trial and error to balance what's on the left side of the reactants to the right side with that of the products. Okay, so we had actually performed this equation here, and we'll see that here in just a few minutes when you're in class, where it's theorized that if there was a Civil War rocket, that oxygen was going to be the oxidizing agent. And in order to do that, it was theorized at one point that mercuric oxide, or HgO, okay, would then decompose into its associated parts, which would just be mercury and oxygen. And one of the aspects we said, please remember this, that when we're doing this reaction, gases and halogens are diatomic molecules, and that's why that little 2 is there. Okay? So then when we start choosing coefficients, then that's how you see that there's a 2 in front of HgO, and then also just a 2 in front of that of the mercury when it breaks down. And that's what we would see here. There's 2 oxygens there, so we put a coefficient of 2 here. So then now that 2 gets distributed through, now our oxygens are balanced, so we put a 2 here to balance that of the mercury. Okay, so that does it for our series of balancing the chemical reactions. Now we're going to put that to use with that of the classifying these types. Okay, we said we wanted you to put down combustion reactions, which is CB, synthesis reactions, which would be SY. Okay, and we'll go through some examples here shortly so you can place the type of equation to the abbreviation, and so we can illustrate what's actually taking place. So we've spent some time on this with these combustion reactions. You're always going to have the same byproducts, carbon dioxide and water, or CO2 and H2O. Okay, and we know we're dealing with a combustion reaction when we have those byproducts reacting with a diatomic molecule of oxygen because it's burning, and then we are dealing with that of a hydrocarbon. CH4 is the simplest hydrocarbon, so therefore we know that is a specific reaction of combustion. CH4 plus O2 would give CO2 and water. And we also wanted you to be able to recognize, okay, the idea that when it comes to what we call alkanes, like CH4 is C2H6, C3H8. If that hydrocarbon is odd, you just leave it alone. C3H8, you would just leave that alone. C2H6, however, since that carbon is even, you would double that right away. When we're dealing with synthesis reactions, we are taking 2 substances and combining them, which is the exact opposite of a decomposition type. So what that would mean, okay, if we took these 2 substances and combined them, we would get mercuric oxide. We're taking again, a metal and a gas here, combining them to synthesize or make mercuric 2 oxide. Just the opposite of that is when something decomposes, it's breaking apart into its associated pieces. Those reactions are reversible. In other words, the exact opposite of synthesis then is decomposition, and that's what this one would be. If it's going to the right, like this arrow would say, that is decomposing. But if we flipped this arrow and was pointing to the left, we would say that is a synthesis reaction. 2 or more substances combining to form a more complex substance. Again, that is a synthesis reaction. And most simplest type would be hydrogen plus oxygen making water, okay? And in a lot of these instances, as you can see, heat and light would be given off. Okay, so let's put some of this context to work then, all right? Okay, so let's go ahead and get the little board in here. All right. Because again, not all these reactions are going to be given to you where they're written out. You're going to be given the words, and you have to write the element or compound and illustrate what's happening. So like that last one, if we had hydrogen, okay, plus oxygen, okay, we know that's going to give us water. Okay, so remember, when we're dealing with both of these, they are gases. So that means H2, it's diatomic, along with our oxygen, which is from a prior example, we know is diatomic, and then gives us our water. Okay? So our hydrogens are balanced, but our oxygens are not. So if we put a coefficient of 2 here, that gives us our 2 to 2 for our oxygens, but 2 times 2 gives us 4, so we put a 2 here. So our coefficients then would be 2, 1, 2. Again, nothing changed here, so 2, 1, 2. A synthesis reaction. Okay, so again, an example of a combustion type. Let's say, for instance, we would have C8, okay, H20, okay, octane, not H2O, H20, okay, oops, not 20, 18, okay, and then we're adding, again, a diatomic molecule, oxygen, and that gives us our byproducts of CO2 plus H2O. And again, one of the things we wanted you to recognize in these combustion reactions is that since this number is even, we want you to double that right away. Because if you don't, again, this is what would happen. This would be fine. This balances out your carbons. Then we would look at this and say we got 18 hydrogens and 2 over here, and take that times 9. Now our hydrogens are balanced, but when we look at our oxygens, we've got 16, we've got 9, that gives us 25. That gives us an odd number. So remember, if this is an even number, let's double that right away. So when we do that, our oxygens will now balance out. So if we double this, okay, 2 times 8 will give us 16. We've got 1 carbon here, so you take that times 16. Our carbons are now balanced. However, 2 times 18, okay, would now give us 36, and we put an 18 there, and now our hydrogens are balanced. The last one to do is our oxygens. 16 times 2, 32. 18 times 1, 18. Adding those two together would give us 50. So 50 oxygens are on our product side. On our reactant side, we only have 2, so we put a 25 here. So our lines would be 2, 25, 16, and 18. Okay, again, combustion reaction. All right. Okay, decomposition, we had shown you an example of that, and that was that of mercuric to oxide, decomposing to mercury and oxygen. Okay? And that's what we're illustrating here. Substances break down into simpler elements or substances. Decomposition. Okay? Then our last two types, as we can see, are single replacement and double replacement. All right? So we won't quite get into the definitions of those, but we will show you an example of a single replacement and double replacement. Okay. All right. So an example then of a single replacement would be as follows. Okay, let's say we would have some, I don't know, we'll say sodium. We'll go sodium nitrate. We'll just do that. Sodium nitrate, okay, and then we're going to add some lithium to that. No, let's make it calcium. Okay. And what we see happening, we know that this is a single replacement because we see a lone metal, a substance or an element all by itself, which would then, okay, single replacement, here's your clue, we see a single metal all by itself. So what this does, this calcium then replaces that sodium, okay, and then what would happen, actually I think a better example would be, let's use beryllium instead. Beryllium, again, also a lone metal, is still a single replacement. Beryllium, we see a lone metal, we'll kick the sodium out of there, so that gives us Be, okay, and then, oops, beryllium nitrate plus sodium, or Na. I'm kind of running out of space there. Na. So our formula, as we know, for sodium nitrate, sodium is Na. The nitrate ion is NO3. Okay, we're adding beryllium to this, or Be, and it gives us some beryllium nitrate, Be, NO3 plus sodium. Now, remember, when it comes to some of these subscripts that go from one side to the other, we know that that 3 has to go over because the 3 is part of the nitrate formula. So we always want to keep that in mind. Okay? So, as we do this, go by your negative ions. This is -1, +1. Beryllium being in column 2, we know would form a +2 charge. These do not change. That's -1. That's being in column 2. So that does not add up to 0. So least common multiple between 1 and 2 is 2. And when you find that, remember, the answer you get from that division tells you what to put below. And even though it says -1, that's not a value, that's just a charge. 2 divided by 1 gives you 2. So we put that here. Okay? Therefore, we put that in parentheses, and now we've got our equation ready to go to be balanced. Okay? Because now all the charges will add up to 0. So we've got some sodium, we've got the nitrate ion, and usually it works out a lot easier to just keep your polyatomic ions together. Sometimes you have to split them up, but since we see the nitrate ion on both sides, we'll keep them together, and then we see some beryllium. Okay, so how we start this: sodium, one on the left, one on the right. Beryllium, you see one on the left, one on the right. Nitrates, we got one on the left and two on the right. Okay, so we've got 4 blanks here. 1, 2, 3, and 4. They're all 1s right now, but since we've got 2 nitrates to 1, we're going to put a 2 here, distribute that through the entire compound, changes that to a 2, but also changes our sodium. Okay, so now our nitrates are balanced, but our sodiums are not. So we're going to put a 2 in front of here to change that to a 2. Now we've got a balanced chemical reaction. Again, it's single replacement. We know that because we've got a lone metal all by itself. That is a clear indication of a single replacement reaction. So we see 2, 1, 1, 2. 2, 1, 1, 2. And again, SR, that would be a single replacement. All right. So then a little bit more complex, we've dealt with balancing these, and that would be a double replacement. Okay. So let's go ahead and look at something like let's do, how about some potassium nitrate plus, I don't know, how about some sodium not sodium hydroxide, magnesium hydroxide. Okay, and we see 2 compounds. We see 2 compounds on the left. That's an indication of a double replacement reaction. So what we see happening is it splits apart between the positive and negative ions. They will not change from one side to the other. So what I want you to do is, for a moment, get that caught up and put your charges in there. And as we complete that, I want you to think about which one, if any of them subscripts, will go over to the right for sure. And there are some that do, or that will. Remember, this is positive 1, negative 1. This is positive 2, that's negative 1, and we've got 2 of them. So of these 2 subscripts, which one is going over to the right for sure? And it's going to be this one, because again, this is part of the nitrate formula. So the positive ion of one bonds to the negative ion of the other. The positive ion of this one bonds to the negative ion of that one. So potassium and OH plus magnesium and nitrate. Okay, positive 1, negative 1, positive 2, negative 1. These charges add up to 0, so that's good. These do not. Least common multiple is 2. 2 divided by 1 gives you 2, parentheses, and 2. All right, so we'll allow you to decide how you want to balance that with some extra practice, but it looks to me like your answer would be 2, 1, 2, 1. 2, 1, 2, 1. 2, 1, 2, 1. Again, double replacement reaction. And we'll have some more examples set up for you in the future, and you'll have some papers assigned to you for the throughout the day. There'll be 2 separate worksheets. One that is 1 through 10, and another one is 1 through 20. Okay, The one that is numbered 1 through 10 is just a front and a back. That will be due on Tuesday, which would be the 12th. Okay? Then the other paper, which is 1 through 20, will be due next Thursday. And on Wednesday, the 13th, we'll be having a quiz, a problem quiz on balancing chemical reactions. That's a little later next week. Let's hope we're here for the duration of next week. But due to possible weather, we will have these handed out for you and some extra, let's say, presentations to help point you or guide you in the right direction should we not have class next week. So it's your opportunity to ask for help. It's your opportunity to go to the Science Channel and view this. It's your opportunity to help yourself out. So that's a breakdown of next week. We will catch up with you next time.